All right, today we're looking at polar equations and graphs day 2. This is like the polar with calculus lesson. So we're going to be looking at like some of the calculus concepts, at least to start. So the first one is finding the points of vertical and horizontal tangents. We saw this when we were doing parametrics, but we need an x and y to be able to do it. We don't have an x and y in here. Well, we had those formulas from pre-calculus, where x is equal to r cosine theta and y is equal to r sine theta. Well, this allows us to create an x and y, and then we can take the derivative of them to get a derivative of x and a derivative of y that we can set equal to 0 for horizontal and vertical tangents. So let's start by actually finding these equations. X of theta is going to be r, so this equation, times cosine. So we're going to have 2 cosine theta minus 2 cosine squared theta. And we'll do the derivative because we want the horizontal tangency, so we want where the derivative is equal to 0. That's going to be 2 sine theta, sorry, negative 2 sine theta, plus 4 cosine theta sine theta. We'll set it equal to 0. And then we'll factor out a sine. So we have, I'm going to factor out a negative 2 sine. Then we have 1 minus 2 cosine theta. Set it equal to 0. We get sine is equal to 0. Cosine is equal to 1/2. Sine is equal to 0 at 0 and pi. Cosine is equal to 1/2 at pi over 3 and 5 pi over 3. Now we can't say for sure what tangencies these are until we check y as well, because remember, if both of them share a tangency, it's a point of rest. So let's do it in different colors for the y. Y of theta is equal to r sine theta, so we have 2 sine theta minus 2 cosine theta sine theta. Take the derivative. It's going to be 2 cosine theta, and then we're going to have to do product rule for the second part. So negative 2 cosine squared theta plus 2 sine squared theta. This one's going to be a little bit harder to find though. We set it equal to 0, and we realize we can't get anything by itself. So we're going to need to get it all in the same terms of trig functions. So what I'm going to do is I'm going to change this 2 sine squared theta into 1 minus cosine squared theta, and we'll distribute the 2 there. And if we combine these properly, we should get negative 4 cosine squared theta plus 2 cosine theta plus 2. And this can just be factored like a normal trinomial. We'll pull out a negative 2. And then we factor it and get 2 cosine theta minus or plus 1 and cosine theta minus 1. So we get theta equals, cosine is 1 at 0, cosine is negative 1/2 at 2 pi over 3 and 4 pi over 3. So these are all of our tangencies. We have vertical tangencies when x prime is equal to 0, so these would be our vertical tangencies. And we want to write them as coordinate points. Now we're not going to use 0 because it's shared for both of them. So we have pi and we need an r. We'll plug it back in to get an r. We plug pi in here and we get 4. We have pi over 3 and 1, and then 5 pi over 3 and 1. So those would be our vertical tangencies. Horizontal tangencies, we end up with 2 pi over 3 and 3, and then 3 and 4 pi over 3. So those are the points that we have vertical or horizontal tangencies. Now let's keep moving. Let's take this a step further. Let's say we want to find the specific slope at that polar coordinate. Well, slope is dy over dx. And in polar, that means we're going to have dy over d theta over dx over d theta. Which means we're going to have y prime of theta over x prime of theta. Now, we want this to happen when theta is equal to the theta they give us, pi over 2. So we can go back to that last page and we say y prime of theta is 2 cosine theta minus 2 cosine squared theta plus 2 sine squared theta. And we can say x prime of theta is going to be negative 2 sine theta plus 4 cosine theta sine theta. And we want this when theta is pi over 2, so we can say dy over dx at theta equals pi over 2 is equal to, well, y prime of pi over 2. Every time we plug pi over 2 into cosine, we're going to get 0. So that's going to be 0 minus 0 plus 2 times sine squared of pi over 2. Well, sine of pi over 2 is just 1, so that's 2. Over negative 2 times sine of pi over 2 is just 1. Plus, and there's another 0 right here. So we end up with negative 1. We can even take this a step further by asking you to find the equation of the tangent line. In that case, you need to use this theta to find what y equals and what x equals and find the equation of the tangent line. All right, that's it for today. Let me know if you have any questions. You'll have a great